Well, good evening and welcome to Dome at Home, the Manitoba Museum's live astronomy planetarium show thing. I'm your host, planetarium astronomer Scot Young, and I am happy to be here. It sort of crept up on me. June went by in just a few minutes, it feels like, and all of a sudden we're ready to do a show again. We're at that point of the year, of course, where it really doesn't get dark. Summer solstice was a few days ago. That's the longest day of the year, as they say, even though the day's still 24 hours, but the longest amount of sunlight. And the sun doesn't actually get below the horizon enough for twilight to ever end after sunset before it actually starts again before sunrise. So we have this I don't know, about 5 or 6 weeks of perpetual twilight centered around the June solstice. And so if it feels like it doesn't get dark until way after you're asleep, it's not just you. That's the joys of living in mid-northern latitudes. It's basically the same kind of thing as the midnight sun, except not quite as extreme. We just sort of have the midnight twilight. So that's what's going on. I think it probably affected a number of us doing observing. I know that between that and the rain, I don't think I've had very much observing time at all since the last show. And up until yesterday, I only had a few pictures submitted, but so I posted, and you all came through, and we got a whole bunch of pictures in for the show today. So thank you everybody who submitted, and we'll see your images in just a little bit. Let's see. So today we're going to be talking about a few different things. We've got, the midnight twilight that I was talking about makes it a great time to see satellites, and makes it a great time, in fact, the only time to see these ghostly electric blue clouds that sometimes hover around the northern horizon. They're called noctilucent clouds, and we've got a little bit of explanation on how you can see them, and some great images from some top-notch astrophotographers who have been kind enough to let us use their images. Let's see. We also have the part 2 of our series on the moon landers that are being built for the Artemis mission. Now, in the last month, a number of bits of information have come out from NASA, and in fact, they also have a press conference coming up on June 30th, so just in a few days, to talk about even more missions that they're going to be launching, not human missions, but the landing and the cargo and the test missions and things like that, that will lead up to these moon landings. So we'll talk about moon landers, and there's a bunch of other cool space stuff going on. We'll also give a little highlight about what the summer sky looks like, what you can see, and yeah, it's a jam-packed show. So let's jump right in. Remember to say hi. Nice to see a few of you jumping into the chat here. It's always great to see everybody and see what you're up to. Devin, hey, yeah, noctilucent is a good word. It means basically night glowing. So these clouds seem to glow in the dark. And you'll see. There's another less cool name. I think they're polar mesospheric clouds is the other technical name. I like noctilucent. All right, let us jump into some images here. Here we go. Brian, nice to see you in the chat there. And Brian sent us some images of the blue moon, which was on May the 31st, second moon in the month, a nice full moon. And this really highlights the differences in what we call focal length. If you've got a camera and you can zoom in on a phone or whatever, well, if you have a camera with a lens, like a DSLR or something like a telescope, it has what's called a focal length. And the focal length essentially is how much magnification the image gets. And so here, Brian's using an 18 to 250 millimeter lens. So you can zoom from the low version, which gives you a nice small moon there, all the way up to like 250 millimeters is basically almost a telescope. And you get a much larger image scale. It's a little harder to keep things nice and steady. And so I'm not sure how it comes through on the image here on the stream, but the big image is a great shot of the full moon. I can see just a tiny little bit of wiggle compared to the small image if I blow them up to the same size. And that's only because when you're holding a camera and pointing it, any little wiggle that you're doing will get magnified by the focal length as well. And so it's much harder to shoot pictures with a longer focal length. That's why telescopes can be so complicated. They usually have a really long focal length, and so they have to be mounted very, very firmly. But regardless of all that, these are great shots. And thanks, Brian, for sending them in. It's always nice to see your work. And we have another full moon coming up in about 3 weeks. We can check out. All right. Gia sent in some pictures. Gia Walker's been doing some Milky Way stuff, and we're going to have Gia on the show next month to talk a little bit about how she does these kinds of nighttime Milky Way shots. This is a shot, I think that's the Pinawa Dam there, so out in a nice dark area of the province, as dark as it gets at this time of the year. And just a beautiful view of the center of the Milky Way there. Let's see if my pointer will come up. Yeah. This little dark area here, this is looks like the horse. This is the horse's head and its body and its legs. So it kind of looks like a little dark horse there in the sky. The core of the Milky Way is down there. Actually, why don't I just do this? There we go. So there's your constellations: Scorpius, Sagittarius down near the bottom. Scutum, the shield, a very inconspicuous constellation that is really in the heart of the Milky Way there, down below the Summer Triangle. And the parts that we've been talking about for months now, the Summer Triangle is sort of up to the upper left of this. All of those little circles are great binocular targets for your observing in the summer. There's little clusters of gas, the nebula, that are places where stars are being formed. There are star clusters. The Sagittarius star cloud is just a really dense part of the Milky Way there. Way down at the bottom, there's a little cluster there that we'll talk more about next month. And yeah, just all these little things you can see. Basically, go out to a dark location, avoid the moon, look at the Milky Way, and pretty well anywhere in there that you point your binoculars, if you look around and carefully, you'll find all sorts of little jewels in the sky. It's a great part of the sky. Thanks, Gia, for giving us the image there. And it's a beautiful shot, as always. I love your landscape compositions, as with the astronomy stuff sort of in the background there. Tracy has also been doing some moon stuff. We saw some of her images last month. And she's back again with her telescope and just a phone through the camera, or a phone camera through the telescope, but definitely got some great images there. This is on the 19th, so a nice crescent moon with some of the beautiful craters along the terminator there, and managed to get shots the next night as well, so you can see the difference. And she wrote that you can really see how much the phase changes over one night. I mean, that's a significant change from there to there. That's 24 hours. And of course, the moon is moved in the sky, and so we're seeing more of the lit part. So the moon really does change, even hour to hour. If you watch it carefully over the course of the night, you'll see changes along that shadow edge as the sun rises or sets. Beautiful images, Tracy. Thanks for sending those in. And I always, people talk about the man in the moon, and they draw the picture of it, and I never see it that way. I actually see the man in the moon just on this side of the moon. This is one of the eyes. This is Merycrisium, I think, and then this is one of the other eyes, and then his nose is this bright part here, and then his cheeks are kind of in shadow, but his mouth would be down here. It's kind of like there's a light on top of him shining down, and just the top is lit, and his eyes and his cheeks are shadowy. It's very creepy, actually. Anyway, that's the man in the moon that I see. Paul Schreckenbach was down in New Zealand, and Ulrika sent in these images so that we could get a view of the southern Milky Way. Here we've got the Milky Way from New Zealand, and so you're looking at parts of the sky that we cannot see from here in the Northern Hemisphere. And I didn't get a chance to annotate this image with the constellations and things like that, but this is sort of the center part of the Milky Way here, and all this stuff down on this side we can't see at all. And just a glorious shot. So thanks, Paul, for sending that in, and great to hear from you on your travels. And you can't go to the Southern Hemisphere without looking at the Southern Cross. The Southern Cross is one of the most famous constellations that most people have never seen, and it doesn't really look like a cross like the Northern Cross does, because the Northern Cross Cygnus the Swan has stars down the middle and then stars that come out from the middle, and it looks like a cross. Well, the Southern Cross doesn't have a middle star. There's no star in the middle there, so this actually just looks kind of like a diamond. But anyway, that's the Southern Cross. Very, very distinctive part of the sky. Nearby is Alpha Centauri. This is the nearest star system to us, only about a little over 4 light years away, and it's a triple star system. And the closest of those three, Proxima Centauri, actually has 2 or 3 exoplanets, if I'm not mistaken. So we've got a planetary system relatively nearby, which is kind of cool. And then the coal sack. There's again, the dark clouds in the Milky Way. There's a really, really dark one right next to the Southern Cross that is very, very distinctive. I've never seen it in real life. I've seen it in the planetarium many times, though, and it's something that people that do make it down below the equator talk about in terms of something that you can really see structure in the Milky Way in that part. So yeah, let's see. What else do we have here? So this is really cool. Ivan Yun is one of the members of the local center of the Royal Astronomical Society of Canada. He's a top-notch astrophotographer. He's been doing a lot of solar work, looking at the sun with proper filters and stuff. So here you can see, the flames on the edge of the sun and the sunspots and the little filaments and things. It's just really high detail. Well, he started taking time-lapse. So you take a bunch of images and process them every few minutes or so, and then you can make a little movie of what's happening. Well, he happened to do it just when the big solar flare went off on June the 21st. It was an X-class solar flare, and this sunspot over here, I think I put a little marker here. Watch the changes there. This is the change in about 25 minutes, I think. It went from sort of, a little white spot to suddenly being super big and large and overloading the camera in that area, basically overexposing because it just burst out. It's really rare to catch that when you happen to be imaging. So well done, Ivan. That's a great image and or a great series. And it really demonstrates, the sun's always doing stuff. After seeing this, I kind of think maybe I should dust off the solar gear and give up trying to stay awake until the stars come out at night, and in the summertime just go right over to solar observing because the sun's up a lot. All right, Krish down in Texas with his Dwarf 3. He's been sending us images. I think you've given us an image, at least one, every show for the last 8 or 9 months straight. So well done. This is the Wild Duck Cluster, M11, Messier 11, a beautiful little star cluster just off the tail of Aquila. It's in that constellation of Scutum that I mentioned that is not something that people know about in most cases, and it's right in the middle of the Milky Way. So a beautiful little star cluster there. And this was just taken, I guess, 2 nights ago. I thought we had another Krish one there, but I guess it's coming up a little bit later. Ulrika has been out and managed to get, how did you get clear skies for the Venus and Moon thing? Good for you. Well done. So there you got the crescent moon and Venus in the left frame, and then just the zoom in with the of the moon there. And you can see craters and so on. Ulrich said, this is just with my phone camera, and I was impressed that I could get so much detail with, just handheld and without any fancy gear or things like that. Great shots, and that was a good night to be out. Here's the other Krish picture. This is the Veil Nebula. This picture has so much in it. I could probably do 10 minutes on just this image because, so you've got all the stars of the Milky Way in the background, and then you've got this sort of wave of gas, and behind it there are a few other fainter waves. This is the shock front of a supernova explosion. A star reached the end of its life, it exploded in a supernova, the shock wave blasted out into space, and then it is compressing all of the gas and dust that's floating around in the galaxy, and so it's getting sort of swept up by that pressure wave of the supernova, and as it gets compressed, it starts getting denser and denser. The parts get closer and closer together. Gravity starts to take over, and it can attract things to each other once they're close enough. And then you start getting the material forming clumps, and then eventually you get more material that can be made into the next generation of stars. So this is basically stellar recycling going on, caught in the act. Now, obviously, it takes way longer than we can image over the course of a human lifetime to do any of that. But still, a beautiful object. The Veil, when I was a kid, the Veil Nebula was like one of the holy grails. Like if you could see the Veil Nebula visually, you knew you were in a dark place and you had a good telescope and maybe a good filter. And if you could image it, you were working really hard. So well done, Krish, to be able to pull that in with the dwarf. And it says duo band here, so it's using one of the filters that is perfect for finding this kind of object. I have one of these smart scopes waiting to be delivered, so I'm looking forward to getting to try one out myself. Alan Dyer is an astrophotographer of note, shall we say. He's one, I mean, you'll see his stuff in Astronomy and Sky and Telescope magazine. He's had, I don't know how many astrophotos of the day at NASA and stuff like that. He's a phenomenal photographer. Winnipeg boy originally, and then he's off in Calgary now, and off near the Badlands. And you get this beautiful view of Venus, Jupiter, and Mercury. So you've got Venus right up at the top, Jupiter when it was just coming by on the 8th, and then down in the haze here, and probably hard to see, so I just did a little enhancement. Oh, let's see. There's Mercury. Let's see if I change the contrast a bit. You might see it. Kind of hard to see in the stream unless I zoom in. Sorry about that. But a beautiful image. And this captures that moment of the three planets being in the sky, the bright stars, Castor and Pollux up there as well. Beautiful foreground as well. And like we sometimes see in GIA's images, every once in a while there'll be a cloud or something like that. In this case, the clouds sort of add to the drama, you know, blocking out the sunset and things like that. Oh, hey, Alan, nice to hear from you. You were the planetarium's first intern back in the day. The planetarium. Well, Alan's been a planetarium guy most of his life. He wrote all sorts of amazing award-winning shows in Calgary, and I think he worked in Edmonton as well. Hey, anyway, one of my heroes, and somebody that I've gotten a chance to get to know through both planetarium and astronomy stuff. Where was I going with that? Oh, so you've got these dark clouds here, but we've also got, and it's kind of a little harder to see, but along where the title is, there's these blue clouds that they seem to be farther in the distance, and they don't look the same as other clouds. Now, if they're up high, and so the sun is still shining up there, but even after it starts to get dark, sometimes those blue-white clouds still hang around. And those are the noctilucent clouds we were talking about. So what we're going to do is we're going to flip over to just another set of images here. And we're going to look at these kind of ghostly clouds, noctilucent clouds. Here's something that I kind of knew, but I wasn't fully aware of. There's no record throughout history of these clouds being seen before about the 1880s. Like, this isn't like the Northern Lights where there are historical records of people seeing them forever and ever. This is a relatively recent phenomenon. And that's kind of cool because, you know, you kind of think that weather has been around forever and, you know, it's not going to be any different now than it was 1,000 years ago. I mean, climate would change and things like that, but a cloud's a cloud, right? Well, these things are very, very recent. This is a great shot by another good friend of mine, Bill Crosney, who's back in the RASC Winnipeg Center as well, and he's got a special interest in noctilucent clouds, so he let me use a couple of his images. They're really ghostly, and when you see them, like many things in the universe, a picture can't always convey the same feeling as seeing it live. Like, these are really glowing, kind of almost iridescent, no, maybe not iridescent, but like electric blue clouds that really stand out against the dark sky. So what are they? And why do we only see them around this time of the year? Well, it has to do with basically where they are. here's your daily dose of science. The Earth has an atmosphere, and that is something that we're all aware of, but we only care about what's called the troposphere. This stuff down here, that's the only part that really matters to us. Oh, my pointer disappeared. Oh, that's too bad. Anyway, the troposphere down at the bottom, that's where the weather is. That's where the oxygen is that we breathe. That's where planes fly up to, mountains, oceans, all that kind of stuff. Up about to 10 kilometers, maybe a little higher than that for some jets. Up above that, you get what's called the stratosphere, and that's a really thin or a really tenuous atmosphere. It gets quite cold up there. If you look at this graph on the right, you can't because I'm in the way. Let me do that. There we go. So the graph, the red line there sort of indicates at surface level, your temperature might be 20 degrees Celsius. Once you get up to 10 kilometers, though, it's down to minus 60. So it's pretty cold. And all through the stratosphere, it's in the minus 40, 50, 60 range. So really, really cold. Above that, it actually gets warmer, which is kind of cool. And we'll maybe talk about that as well. But the stratosphere it feels like space, I think. Up above that, the rest of the atmosphere is so thin that it's almost not there at all, except for really specific things. For example, like you wouldn't be able to breathe there. You wouldn't be able to fly a plane there because there's not enough air for the wings to dig into anything and be able to control it or things like that. Rockets work, but there's enough air there for a few things to happen. There's enough air to cause friction with incoming space dust to make meteors, shooting stars. There's enough atmosphere to let water vapor condense into clouds. But where does that water vapor come from? I mean, you're up at 80 kilometers there where it says noctilucent clouds. The water is all down at the bottom in the ocean. How can it possibly get up there when it's minus 60 degrees between those two places? Well, there's a bunch of interesting theories. The best answer is we don't 100% know, but we think that noctilucent clouds are actually essentially human-caused. The 1880s was sort of peak industrial revolution kind of time. Lots of industrial pollution and things like that, particularly methane. And what seems to be happening is the methane up at high levels is converting into water vapor and making these clouds. And they're there all the time, but they're so thin that they're invisible most of the time. In the daytime, you wouldn't be able to see them because they're just so thin. And at nighttime, same thing, you wouldn't be able to see them because they're just so thin. But right at sunset, when, the Earth being round, it's dark down here, but the sun is shining up into space up above us. We'll see satellites go overhead because they're still lit up while it's dark down here. Well, the same thing with noctilucent clouds. The best place to see them is along the northern horizon around sunset and a little bit after sunset. So if you want to see these beautiful clouds and maybe take some images of them, basically you're looking towards the north along the horizon as it's starting to get dark. And you're actually seeing these things that are very, very high up in the sky. This is a shot from space, and look how thin the atmosphere is compared to the planet. Like the edge of the planet there is just a tiny, thin little band. And noctilucent clouds sort of happen right at the top of that. This is a shot from the space station. I might have cropped it a little bit, but right at the bottom of the image is basically the edge of the Earth. And this orange layer here, that's the troposphere. That's the 10 kilometers that we live in of atmosphere. And there's kind of a hard line there because there's basically a definition of the layer. And then above that is the stratosphere out to about here. And then above that, the mesosphere. And here are some noctilucent clouds floating around there. And of course, the moon is photobombing things from way off in the distance. But this is a nice sort of real-life view of that schematic diagram that we showed. So these noctilucent clouds are out there pretty much all the time. And they can be really beautiful. Even when there are other clouds, like when you look at them, you can tell that those blue clouds, those white clouds, are much farther away than the dark clouds that are, blocking them out. Um, and in fact, they even feel like they're farther away than the sunset colors. They feel like they're way over the horizon, and they are. You're looking at essentially clouds that are very far away from you. This is another great shot from Bill. And let me see here. Bill also got an image of these clouds. He's really nicely composed here. I think that's the lake. And then you've got all the sunset colors, in the distance, noctilucent clouds. And then way off here, you've got Comet Neowise. This is back in, geez, what was it, 2020? We had this nice bright comet that popped into the sky for about 2 weeks that was visible to the unaided eye. And one of the best nights that I went out shooting it, there were also these noctilucent clouds. Now, Bill got a much better shot than I did of it. I was just shooting with a cell phone. But Alan, off in Alberta, he's got a great spot out of town and some pretty nice horizons. And actually, if you're interested, you can check out his website, AmazingSky.com. He's got a couple of ebooks there talking about how to do nightscapes and how to do time lapse and things like that. Some really, really helpful resources. This is one part of a panorama that stitches everything together, and you've got those beautiful noctilucent clouds in the back. Oh, excuse me. Sorry. These beautiful noctilucent clouds in the background. I think we've got, here's one of the panoramas. Alan, being a planetarium guy, likes to stack things together and make large formatted images, and he's got some great panoramas. And that really, I think, shows the beauty of these kinds of clouds. So this is the season. This is the one highlight of astronomically of this time of the year. Everything else is hard to see, but the beautiful noctilucent clouds, you've got a few weeks to check them out. So try and see what you can get. Yeah, here's my comet, and there's some noctilucent clouds. This was just with a cell phone, so not really a great shot, but it's amazing how easy it is to spot them. All you have to do is go out at the right time. So, ghostly blue clouds, this is the time of the year. Go out and check them out. It was, thanks, Alan. Yeah, it was great to see, great to chat with you a little bit today. And yeah, you guys have some great shots of the noctilucent clouds. Let me go back here in the chat, because I saw a few things going by. Oh, Ulrika was up at Nauza Provincial Park for their shot. Great, that's where that was. Let's see. So yeah, some really great photos. Thanks, congratulations to everybody that sent stuff in. If you want to see your images in the show, just let us know, and we'll be happy to add you to the. That was a little bit weird. There we go. Wrong camera. That we'll be happy to show your images. Sylvia's asking about the asteroid on Saturday. Yeah, we'll talk about that in just a little bit. There's an asteroid coming. I've been watching it for about a week or so, and it passes relatively near the Earth. It'll get bright enough to see in a small telescope. I doubt you'll see it in just regular binoculars. It only gets up to about 10th magnitude, and that's pushing it for regular small binoculars. If you have big binoculars or a telescope, you might be able to see it, but it's going to be one of those things where you'll need a specialized star chart to be able to track it down, and it'll look like a star. And if you look at it 5 minutes later, that star will have moved. So it'll be a challenge to track down, but I've been putting together some charts for it, and if we get some clear skies coming up, I'll do a live stream as well. But yeah, we'll talk a little bit more about that. Hollis, yeah, I never noticed the horse in the Milky Way before. Yeah, it's something that I've only seen visually a couple of times, and even then, it's like I think it's more the suggestion of it rather than actually being able to see it like that. Our eyes just can't do the same things as cameras. But if you're in a really dark spot, you can see those silhouetting clouds, And there are some cultures have actually made constellations out of those clouds rather than using stars. There's one of my staff at the planetarium, Dre, does this great thing about the celestial emu that is made up of the dark clouds in the Milky Way from down in New Zealand. Let's see. Karen, oh, first time watcher. Amazing photos and show. I'm hooked. Well, that's wonderful. Thank you very much. You should drop us a line, space at manitobamuseum.ca, and you can, at the place where I work, the Manitoba Museum, we have a monthly blog that sort of lists out a lot of the stuff that we talk about so that people can go and find it themselves. There's star maps and, other kinds of things like that. So you can visit us, or of course, come down to the planetarium. Actually, right now, we're just finishing our school season. Oh, soon school will be done. Wow, it's been busy. But starting on the weekend, we have a special live show called called Milky Way Live. And it's basically, if you go to a park or like the Grand Canyon or something, you can take like a guided tour. Well, this is basically a guided tour of the galaxy as seen from Earth. And so we'll show you the constellations, show you where things are in the galaxy, show you some things that you can see with binoculars or a telescope. And then, of course, we fly around in space and give you a sense of what the universe actually is like, not just from our point of view, but from a more global, universal point of view, I guess. So that's a great show, and you can check that out. And that'll be running all throughout the summer, daily at 2:15. And I think there's two other shows. One is called Aurora, which is on the Northern Lights. And then one is called Voyage of the Stars, a Sea and Space Adventure. And it is this amazingly cute story of a little starfish and a shooting star, these two characters that meet each other. And basically they have a little adventure together. It's a typical kid show, but it sort of highlights how similar exploring space and exploring the deep oceans are, and it's got some beautiful real ocean footage. Like if you haven't swum with manta rays or things like that, you get to see all that in the show. And so even though it's for kids, I actually think it's probably as good for adults too. So anyway, come and support the planetarium. They're the people that let me do a show like this. All right, let me see. We need to switch over. So just when I thought I had the whole studio thing set up, the broadcast software that I used has done an update, and so now all the buttons are in different places. Everything works the same, but they just move stuff around. That's the kind of thing that happens. And yeah, a little bit. What is that? There we go. Okay. So anyway, being a little awkward here. I think what we'll do is we'll check out
cool space stuff.
All right, cool space stuff. I watched today a press conference at NASA where they talked about Canadarm2. This is the big robot arm that Canada built as our contribution to the International Space Station. It's been in space since 2001. It was designed so that, it's got a lot of moving parts. It's got 7 major joints and 2 hands that grab things. And as they were saying in the press conference, it is essential to operating the space station. They basically can't have the space station functional without Canada's arm, which is kind of cool. But one of the joints failed last month, I guess 2 weeks ago. And so they have planned a spacewalk to fix it. And because they knew how essential this was, there are already spare joints and parts on the space station ready to go. So all they had to do was sort of put together their timeline. So starting on the 30th of June, 2 astronauts will head outside and get into their spacesuits, head outside, and basically, so the arm has a hand on each end, and then it's got a bunch of joints that it can move around, and then it's got sort of a big elbow joint here. The one that's failed is actually the first wrist joint on the arm over here. So what they're going to do is they're basically going to put it in a spot and get in there, take off the hand, put that on the side, put in the new thing, put everything back together. It's going to take about 6.5 hours. And during that time, we will have basically amazing close-up footage of one of Canada's signature space bits of equipment. So that'll be a great time to be watching the NASA live feed to see all the ins and outs of Canadarm. And during the press conference, it was really cool to hear, like there was a person from Canadian Space Agency there who was talking about things and, how important it is for our country and how proud we are and stuff like that, of course. But it was the Americans saying, like some of the questions were, is there a point in the space station's life where, the space station's almost done anyway, so you won't fix something else that breaks in the Canadarm? And the NASA folks were like, no. The Canadarm2 will be the last functioning part of the space station because we need it for everything. So I kind of thought it was important, but I didn't really realize that it was recognized like that by non-Canadians. It's always nice to hear someone else tell you that you're really an important partner rather than just sort of hearing it from yourself. So anyway, that's coming up on June the 30th, and so we'll get to watch that next week. Also on June the 30th, NASA is doing another press conference where they're going to talk a little bit more about some of the upcoming moon missions and stuff, but I'm getting ahead of myself. Let's see, here's another bit of space news. SpaceX tested a brand new thing. It's called Starfall, and basically it's a re-entry capsule, and the idea is that if you want to ship something from one place on the Earth to another place on the Earth, rather than putting it on a plane or a boat, you could shoot it up into space and then parachute it down, and it would be faster. I guess it would. It would also be stupidly expensive and the least efficient way of doing it. But I guess when you're a rocket company, a rocket can solve any problem, especially if it can make you money. And so they're doing this. I don't know. I'll be interested to see if they continue with it or if it's really just a matter of like, if you're a hammer, everything looks like a nail. It kind of feels like this is not the best kind of use case for big rockets, especially given the amount of energy required to go up into space, and then the amount of energy required to prevent something from burning up from coming back into space. Anyway, but they've got that going. So that's yet another SpaceX thing to think about. This is kind of cool. So you all know the Hubble Space Telescope. Many of you will have heard of the James Webb Space Telescope. Well, the Nancy Grace Roman Space Telescope has arrived in Florida, and it's about a month away from being launched. And it is basically, it's about the same size as Hubble, except it has much more sophisticated instruments than they had in 1990 when Hubble was launched, or even the replaced ones. And it is got a couple of really cool features that Hubble doesn't have. It's got a really wide field camera, so it can see lots and lots of stuff, whereas Hubble has to zoom in or make mosaics or things like that to see a big area. It's also got something called a coronagraph, which basically lets it point at a star and then eclipse the star with a little piece of material in the telescope so that you can see if there's any planets orbiting around it. I mean, we found planets around other stars, but it's pretty hard to actually see them. We've detected them. We know that they're there largely because they might pass in front of the star and eclipse the star, or they might make the star wiggle a little bit because of their gravity, but it's pretty hard to see them. Well, this thing is going to be able to see thousands, millions probably, of exoplanets. We've found 6,000 exoplanets from the beginning of time to now, and the Roman Space Telescope will probably find 6,000 in its first week of operation, and then every week thereafter. So it's going to be a pretty impressive thing. So that's coming up in a little bit over a month. Speaking of space telescopes, the Swift Gamma Ray Space Telescope is having problems. It's an older thing, and its orbit is slowly decaying. Remember, we said the atmosphere is really, really thin way up there, but it's not zero. Even all the way up in orbit, there's still a little bit of atmosphere up there that is enough to slow down a spacecraft over years and years. When there's lots of solar activity, that actually makes the atmosphere of the Earth puff out a little bit, and that increases the drag on these spacecraft. Well, anyway, Swift is supposed to re-enter in about a month or so, but no. A new company basically put together a mission that is going to launch a little booster up into space. It's going to go attach itself to the Swift Space Telescope, which was not designed for any of that, and it's going to boost its orbit. This is a really cool thing because it's a way of preventing things from re-entering when you don't want it to. Even the older things that weren't designed for like a Canadarm or something like that to grab onto it. They weren't designed to be docked with or anything like that. Swift was designed just, I guess the space shuttle was around, but it wasn't designed to be serviced. So there's no grapple fixtures or anything like that on it. So this is pretty cool. And so we're looking forward to seeing this Catalyst Space Lynx spacecraft is launching on Saturday. And if that goes well, it'll dock with Swift in about a week or so. And then over the course of several weeks, it doesn't have a big engine, so it doesn't boost it all at once, but it just gives it a little continuous kick that will boost it high enough up that the atmosphere isn't going to pull it down again. So that's some pretty neat stuff. Let me see here. Since the last show, they've announced the crew for Artemis 3. So, we all watched Artemis 2, and Artemis 2 was an amazing mission. Here's the crew of Artemis 3. And so on the left, you got Andre Douglas, who was he was the backup for Artemis 2. And then sitting to his right, this guy here, this is Luca Parmitano, who's an Italian astronaut. So again, an international partner on board here. Now, the European Space Agency was, one of the losers when it came down to all the changes that NASA made to the Artemis mission. They were building the European Service Module. They were also building the second stage of the Artemis mission of the Orion rocket, the SLS, which isn't going to be done now. And they had most of the Gateway space station already built and pretty much ready to go. And then all that was canceled. So NASA owes them big time. And so it was not surprising at all to see a European astronaut named to the crew. I'm sure we'll also see Europeans on future crews. In fact, they've announced that there will be a German astronaut walking on the moon in one of the later on missions. The commander of the mission is the third from the left there. That's Randy Bresnik, who is a very experienced astronaut. And then Frank Rubio, his comrade, standing behind him. So the four of them will make the Artemis 3 crew. There was a little kerfuffle because, of course, with Artemis 2, we had a woman on the crew, Christina Cook, who was, frankly, I think a big part of the charm of that mission. I mean, we all love Jeremy, the Canadian astronaut, but everybody around the world loved Christina too, because she just was very eloquent and very poetic, I guess. Actually, the whole crew was like that. But so there was some surprise that there was no female astronauts on this mission. A little disappointing for sure. I mean, they came out with, we pick of the crews that are available at the time, and we pick the very best, and blah blah blah. Yeah, whatever. There are, half of the astronauts in the Artemis program are women, and I'm sure that many of them are assigned to future missions that we just haven't heard about yet, or we don't know. There's going to be moon landings and things like that. The Artemis program was advertised in part as returning the first man and landing the first woman on the moon. But still, it's a little disappointing. However, this is a very qualified crew. I mean, I don't want to take anything away from them, but it was a little unusual. Canada is also getting into the space game. Now, I mean, we've been in the space game forever. We build satellites. We launched some of the first communication satellites because let's face it, we got a gigantic country and running that much wire would be crazy. So, we were big into the satellite game all the way back into the 60s. And of course, we build our own rockets too. The Black Brant rocket series, one of the most used rocket series in the world, is built right here in Winnipeg. Now it's a sounding rocket, which is suborbital. So it goes up like a cannonball, and it comes down like a cannonball. So you get like 5 minutes of space or whatever. So you can do some science that way, but it's not the kind of thing that people ride. And you can't put satellites into orbit. Last month, the Canadian government announced that they would be pursuing sovereign launch capability. In other words, Canada would build a place that we can launch rockets from that could put satellites in orbit, because we've always done it with the US. And as you may know, the US has become maybe less of a reliable partner over the last year or so. And satellites are so important that we can't be without them. I mean, our country depends on satellite technology, as every country does, pretty much in every aspect of modern life. So the idea that someone could tell us that, no, you can't have satellites anymore, is just unacceptable. So the place that's going to happen is out on the eastern tip of Nova Scotia. And in the place that they are going to build this spaceport, they are launching sounding rockets, I think kind of just to make it look like they're doing something, because right now the site is not particularly impressive. I mean, I've been to Cape Canaveral. I've been to a couple of launch sites. This is Canada's spaceport right now. It is a concrete pad with a gravel road to it in the middle of a swamp on the coast. So it's not as cool as Cape Canaveral yet. Now, interestingly, it's in an area that is great for launching rockets if you only care about rockets, but is terrible if you live in Nova Scotia and are a fisherman or care about animals or things like that. It's basically in a nature preserve, and the rockets that they launch prevent the lobster fishermen from going out and actually fishing lobster during the short season. So there's a whole bunch of issues that are brewing around this. I imagine that they will get figured out, but this was one of those projects that, it was announced very quickly because it was an important idea, and I think some of the ideas are still rushing to catch up. Anyway, we may find that we are launching stuff from Nova Scotia in the next little while, and building up our own launch capability there. So that'll be interesting. Okay, so there's always lots of cool space stuff going on, and we didn't have time to get into all of it there because I wanted to make sure we had enough time to just take a look at the current sky. We're heading into summer. Some of you might be heading away from civilization, going camping, heading out to the cottage, going on vacation or things like that. Is anybody out there going to the solar eclipse that's this summer? It's a total solar eclipse that goes through Iceland, Greenland, and then across the Atlantic into Spain. So if you're heading to that, I think it's August 15th, something like that. Let us know in the comments. I'd love to chat with you and just see what, because we can see a solar eclipse from here on that date. It's I think 8% partial eclipse from Winnipeg, so it's really not a big deal. I mean, we're still going to watch it; it'll still be cool, but it's not a total solar eclipse. But that's coming up, and there's a few other things over the course of the summer that I want to bring your attention to. Let me get this ready here. There we go. Okay. So we're using our great program Stellarium here. Beautiful little download free software that lets you show the sky and do all sorts of cool things. And if you're looking off towards the north, you're looking for noctilucent clouds and things like that after it gets dark. Actually, here this is about, let's see, 11:30. That's when it starts to get dark enough that you can start to see some stars. The Big Dipper is over in the northwest, sort of starting to head down. You got your Big Dipper there. These stars here, the two stars in the bowl, point off to the North Star. Not the brightest star in the sky, just a random brightness star, it seems, but it's directly due north. So there's your directions. As the Big Dipper sort of sets for the season, another constellation rises, and that's the one that is on the other side of the North Star, the W of Cassiopeia. So from about midsummer into fall and into winter, Cassiopeia becomes sort of ascendant in the evening, and it becomes easier to see, and the Big Dipper gets lower and lower and harder to see. So if you're always looking for the Big Dipper as your guidance in the evening, you may need to switch over to Cassiopeia for this next few months. Over in the west, we still have some spring constellations. We have, let's see, if you start from the Big Dipper here and you look at the handle of the Big Dipper, it's sort of got an arc to it. You follow that arc and it leads you to the star Arcturus, which is one of the brightest stars in the northern hemisphere. A big distinctive spring sky, one of the first stars you'll see as it gets totally dark. And Arcturus is part of a constellation called Boötes, which is supposed to look like a guy holding a few baby goats and stuff like that, but actually it looks like an ice cream cone with a big block of ice cream on top. That's a spring and summer thing. That's what I see it as. And it's a pretty distinctive constellation to see. The stars are all nice and bright, and it sort of fits together like the Big Dipper stars do. Right next to it is this tiny little, almost happy face of stars. This little arc is called Corona Borealis, the Northern Crown. You probably won't need to pay much attention to it, but it's kind of a neat little thing to spot from a darker sky, because all these stars are nice and close together, and they're all pretty close to the same brightness. Just off to the side of it, there's a star that any day now could explode and go from not visible in binoculars to being about as bright as the stars of the Big Dipper overnight. And we're waiting for that to happen. So that's something that if that happens, we'll obviously we'll trumpet it out through the interweb so everybody can know. As we swing around to the south, we start to see those images or those constellations that we saw in Gia's picture. There's Scorpio down here with the red star Antares. Here is Sagittarius, the Archer, allegedly, although to me it's a teapot. This part, oh, there we go, lift that up a bit. This part looks like a teapot with the spout here and the lid and the handle. And steaming out of the teapot is the steam of the Milky Way. So that's where your Milky Way is. Now, I managed to pick a day that the moon was right there, so I'm just going to change the date a little bit. The Milky Way rising from the south, heading almost straight upwards, a little bit off towards the east. And as we go higher and higher, it goes into a group of constellations over here. And the three brightest stars in those constellations make a big giant triangle, which is called the Summer Triangle. So there's the Summer Triangle, and the Milky Way goes sort of right through it. And even in this, you can see that there are some dark clouds throughout the Milky Way. And one of those dark clouds goes right through up into this constellation here, Cygnus the Swan, and it's called the Cygnus Rift. So this is a spot where you can really see the dark clouds of the Milky Way. And right near that is this little dot with a Z. That stands for zenith. So the way the sky works, basically, the sky looks like a circle all the way around us, and that sort of goes over our head. It looks like a planetarium dome, essentially. And so when you get a star map, it's not a flat map. It's basically a circle like this. And the idea is you have to take your star map and hold it up over your head and sort of rotate it around until those directions match. It takes a little bit of practice to use a star map to find things. If you've got an app with a phone you can just hold it up and it'll show you what's in that direction. That's easier to conceptualize. unfortunately, if you're looking at your phone, you're ruining your night vision, so you're not going to be able to see as much as you would. You know, it's fine in the city because there's so much light around anyway that it doesn't really matter. But if you're out camping, try and get a star map, like a paper one, or print one from Stellarium, and just use a red tinted flashlight or something like that, or set your phone to red mode where it's really, really low brightness and everything is red colored, because that doesn't ruin your night vision as much. It's a shame to drive out into a really dark location where you're hoping to see the great view of the heavens and then ruin your own night vision. You're basically bringing your own light pollution with you. So you got to use your willpower and keep that phone off if you can avoid it. All the way over in the east part of the sky, there's our summer triangle, sort of nice and high in the southeast and up into the south, and that'll be like that all summer. Just rising in the east are the constellations of fall. And we won't spend too much time on them right now because it's not fall, although it kind of feels like it. But I do want to point out one thing. There's this group of stars here that is 4 stars in a big square, and it's got some other stars around it and everything like that. But the square really stands out in the sky. It's called the Square of Pegasus. And on the left side, there's like this chain of stars that goes over here. And there's Cassiopeia. So the W shape is something that's really easy to sort of find. This is an area of sky worth looking at. If you look at Cassiopeia, it looks like the letter W. One side kind of looks like it was squished, but the other side looks pretty, pretty okay. Think of that as an arrowhead, and it points down over this way towards this stream of stars, which is called Andromeda. Right in here, there's a little fuzzy spot. You might even see it on the stream. I hope you can, actually. That little fuzzy spot is the most distant thing you can see with the human eye. That is the Andromeda Galaxy, a totally separate galaxy to our own Milky Way, and it's 2.5 million light years away. So all the stars you see, the planets, everything on Earth, everything you can see at night and in the day, it's all part of the Milky Way galaxy, because it's, the stuff here on Earth is part of our solar system. The sun is one star in our Milky Way galaxy, and everything you can see is part of that, except this little fuzzy spot. The Andromeda Galaxy is another galaxy, and it's not the only one. There are billions of other galaxies out there. Whenever I'm looking out at the stars and you think about infinity and you think about the vastness of space and all of these things, and it kind of blows your mind. And then you realize everything that blew your mind there is just in our galaxy. And there's a whole nother level of mind-blowingness in the number of other galaxies there are in this much vaster universe. You certainly gives you a sense of perspective. And out under a dark sky, especially, away from city lights, no moon, you can contemplate the galaxy. It's a beautiful thing to do, and it's a great summer pastime. I highly recommend trying to get out, especially I would say this year, August is maybe a better bet than July, just because in July we still have fairly bright skies, and then just as that goes away, the full moon comes up. But in August, around new moon, second week of August or so, we have the Perseid meteor shower, nice dark skies, beautiful views of the Milky Way, all sorts of great stuff. So that's a time to plan your astro getaway if you can. I realized that I forgot one little thing in our sky, and it's because I jumped right to the dark sky. Let's just rewind a little bit here. And here, I'll get rid of there we go. As it's getting dark, before the stars come out, the first star that you will probably see will be this very, very bright thing low in the west. And that's the planet Venus. We saw some great pictures of it. It's still around, and throughout all of July and maybe into August, we'll be able to see Venus low in the west right after sunset. That's your main planet action for the summer. The planets Saturn and Mars start to come up early in the morning, but they're not really well placed unless you're up really late. So they're going to get better as the year goes on. So in terms of evening time, we're just with the one planet, Venus, and then all of the constellations and things like that. Still plenty to look for. Okay, let's take a look here at the chat and make sure that we don't miss out on any of the questions. Let's see. Ulrika asked, wasn't there a launch place near Churchill? Yes, there are in fact a number of places in Canada where they have launched sounding rockets. There was the Churchill Rocket Range just outside of town, where the US and Canadian military had a base in the 50s all the way up into the 90s. And they would launch Black Brants and other rockets and things like that. It sort of got shut down, partly as a cost-saving measure and partly because Churchill isn't always the best place to spend a lot of time in the winter. So when they were done doing the things that needed to be done in Churchill, a lot of the work got transferred to other places. There's still the potential for doing work on the Aurora and things like that. But back in the 50s, you needed to launch rockets from the ground to understand things like the ionosphere and the Aurora and things like that. But now we've got satellites that are up there, and so you don't need to launch things up into the Aurora. You can look down on them. And so that side of things has sort of changed. So Churchill is definitely not a big going concern anymore. There were some thoughts about maybe getting it reactivated, but I don't think that's going to be happening. And it would be not a great place for launching orbital rockets, certainly, because sure, if you want to go north, that's great. But what if you just want to go east and west? It's actually much better to be as far south as you can, like towards the equator. Let's see. We had a couple of other questions here. Oh, hey, Yasmina, nice to see you. Forest family, everybody along. It was great to see you at the planetarium a little while ago. Yeah, the looks like a croissant. Yes, exactly. The moon. Oh, Alan, you're right. There was this star that I was talking about that would explode. It's called T Corona Borealis, really poetic name, or T Cor Bor for short. And when it exploded every 80 years, twice in a row. And so the thought was this time it would also explode every 80 years. And that was like a year and a half ago, and it hasn't exploded yet. And so astronomers are trying to figure out, well, why not? Did we get the math wrong? Or, so they're looking back at the old data and trying to predict when it's going to explode. And one prediction was that it would explode tonight. That would be really cool, actually. Because if it does explode, I'll go live again and we'll take a look at it. But I think it's unlikely that anybody will have predicted it that accurately, especially since all the other predictions have been so wrong. Okay, Val. Oh yeah, the distances in space are so beyond our mind's abilities to conceptualize. So astronomers cheat when they deal with this. We invent things like light years, and we take the huge distances, the gigantic numbers, we take all the infinity and the mind-blowingness, and we squeeze it down into this unit, and we call it a light year, and then we say, oh, that star is 4 light years away. And I can understand 4. 4 is fine. And so I pretend that I can understand what that distance means. In reality, it's 39 trillion kilometers or something like that. That number I can't comprehend. So we cheat and we make these units, and we make bigger and bigger units to deal with these bigger and bigger things. So even astronomers that deal with this kind of stuff for a living, you're right. We really can't truly conceptualize things. We have to come up with a few cheats to do it. Kevin, Saturn at 4 a.m. Yeah, Saturn is going to be a good view this year, much better than the last couple of years. We've had Saturn being quite low in our sky. And so now it's starting to rise. Let's see, there it is. So at dawn, Saturn's up in the southeast. Oops, I see that it's not quite in your view here. There we go. So Saturn is, up in the southeast at dawn. And it'll be higher and higher each night. It'll rise earlier and earlier. Eventually, it'll rise before midnight, and I'll be able to stay up to actually see it. But if we take a look at it, this is the great thing about Stellarium. You can just jump in and look at things. There we go. The rings have opened up quite a bit. It actually looks like a planet with rings. Last year, the rings were almost perfectly edge on, and they pretty much disappeared. Here, it actually looks like a planet. And over the course of next year, we'll have a pretty good view. And it gets up nice and high up above all the haze and things like that. So later in the fall, probably towards November kind of time frame, we'll do a live session with Saturn and take a look at it with the telescope, because it's pretty impressive. And I'm hoping that there will be some astronomy events at local parks and things like that. Check in with your local planetarium or science museum or astronomy club to see when they're doing stuff. And if you do something into the winter, you should be able to see Saturn. All right, we have gone over time again. So it's time for me to get back to our last couple of slides here so that we can do the last little bit that we said that we would do. This will be fairly quick, because basically we talked a little bit about the moon missions and things like that already. Last month we talked about Starship's Moonlander and the various issues with that. This month we're talking about Blue Origin's Blue Moonlander. They like the color blue. And it is part of the Artemis mission to go and set up a permanent moon base on the moon, a sustainable community scientific base and things like that. So we saw Artemis 2, which was the test of the Orion spacecraft. Artemis 3 is going to test out both of these landers, the Starship and also Blue Origin. Well, kind of. And then Artemis 4, 5, 6, etc. will land on the moon with various of these landers and begin constructing the moon base. We'll just skip over that. This is the lander that Blue Origin has built. This is the cargo version. It doesn't carry people, and it's supposed to launch. It was supposed to launch later this year to carry material to the southern pole of the moon, so that there would be some stuff there for the astronauts to when they arrive, essentially. That's been delayed a little bit, but this was like their prototype. And this one is mostly complete and ready to go. Now, it's not for people, it's just for cargo, but still it's a lot farther along than the Starship one. So that was why I had more confidence in the Blue Origin kind of thing. The Mark II is the human-rated landers. It uses a lot of the same systems, but it has a crew cabin at the bottom, and then all of the fuel and computers and life support are in the top. It's kind of upside down, essentially. That means you only have a few steps from your crew cabin down here to your moon surface. You don't have to go 10 stories down from like you do from the Starship. And this is slated to land on the moon for Artemis 5, which is at the end of 2028, which is really soon. Just for scale, this gives you sort of a sense. They're kind of part way. There's the Orion spacecraft on the left, and so the Mark I on the left, Mark II on the right, and in the middle, Mark II Artemis 3. The Mark II won't be ready for testing this year as part of Artemis 3, and so they're putting together, some people have called it Mark 1.5. Basically, it's the crew cabin, but it doesn't have the engines and all of that stuff, because it's not landing on the moon. They're just, they're putting the stuff that's important for this mission in, but it's still not a full-up test. And that kind of isn't the best way to do it. It's still way smaller than the Starship, just to give you a sense of the scale there. So the cargo one is kind of all along the way, and I actually think that if it hadn't have been for this, the cargo thing would have been perfectly on schedule. But the rocket that it launches on blew up during a test on the launch pad, destroying big chunks of the launch pad and grounding the rocket. So their first problem is they got to fix their rocket. And they hope to do that by the end of 2026 so that the cargo thing can launch in 2027, and then they can get back on schedule. Here's the test article that they'll be launching. It's going to have, for some reason, they're putting legs on it, even though it's not actually going to land on the moon. But it's got the crew cabin, and it's got life support. They'll be able to dock with it. Astronauts will leave the Orion spacecraft and go into the lander. They'll test out the spacesuits in the lander. They will fly the two spacecraft together to make sure they understand how it all works and things like that. So there's a lot of, this is a robust test of this thing. It's still not the full spacecraft, though, because it's not testing any of the engines or any of that kind of stuff. However, they're going to test that on a separate mission where they send the whole thing to the moon with no people on it and do a complete test landing and actually land on the moon. Both of those will happen before humans actually take it to the moon. So the plan is the rest of 2026, they have to get the rocket fixed. In early 2027, the Mark 1 cargo goes to the moon. In late 2027, that's when Artemis 3 is scheduled, and they'll do this test as well as a test with the Starship mock-up lander. In early 2028, they'll send an uncrewed mission to the moon, a full-up test of the Mark II lander. Also in early 2028, that's Artemis 4. That's when the Starship HLS is supposed to take humans to land on the moon. I doubt that will occur, certainly on that timeline, because as we said last month, the Starship is nowhere near being able to do any of that. And then in late 2028, Artemis 5 will take the Blue Moon Mark II down to the surface of the moon and walk around on the moon. Now, they haven't announced crew for Artemis 4, 5, 6, anything like that. A lot of this is very speculative. I used to think that the Blue Moon one was a better option than Starship, and I still think it is because it's simpler. It's not trying to be everything. It's just trying to land on the moon, and that's a big enough job without making it also have to be able to spit out Starlink satellites or be able to take 1 million people to Mars or all those other things that Starship will be designed for. Having said that, there's still a lot of work for them to do, and having their rocket blow up did not help anybody. So at this point, we've been given more information, but we actually have really less information than we did in terms of whether this is all achievable. Everybody's saying, yeah, no problem, we can do this. But this is a faster development thing than has ever occurred before, and certainly they weren't working this fast last year. Both of these landings were supposed to have occurred in 2024, and they haven't. So I don't know why we should believe that this schedule will hold when none of the others have. But still, I feel that this is probably the most likely way that humans will get back to the moon from North America. I think it highly likely that the Chinese program, which is sort of operating under secrecy, but they're also not trying to develop a commercial space industry or things like that. They're doing it as a state-run program. So that means there's one boss instead of a whole bunch of rich people that want to do what they want. I think it's likely that China will be able to make great strides before then and may even beat the Artemis program to the surface of the moon. We'll have to see. It certainly will be exciting. The joy that we saw in Artemis 2, I don't know that we'll necessarily have that with Artemis 3. They're not going out to the moon. They're just going into orbit and doing a bunch of engineering tests, and it's not going to be nearly as cool of a mission, I don't think. But we'll have to see. I think it's one of those necessary tests before we can actually get people onto the surface of the moon again and doing those things. So the next few years will be a great time to be watching human spaceflight. And hopefully, we all know that Jenny Gibbons was Jeremy's backup for Artemis 2. That generally means she would get the next flight. And the next flight, well, she's not going on Artemis 3, which doesn't go to the moon, and every other flight goes to the moon. So will we see Jenny Gibbons walk on the surface of the moon before 2030? I hope so. That would be pretty cool. Anyway, it's been a great show. Thank you for all the images that you send in. You can always give us images to show on the show, or you can send in questions or things like that. You can reach us on the socials, or my email is space@manitobamuseum.ca. That comes right to me. And so I can receive big images there or whatever. Thank you all for joining us. Thank you for sticking it out through a fairly long show here. And I hope that you get a chance to get out this summer and check out all the things that are visible in the sky. Next month, we'll be talking about the Milky Way. We'll be talking a little bit about the eclipse. We'll have Ulrika Schreckenbach in with another binocular challenge, and we'll have Gia Walker in talking about Milky Way shooting and things like that. So I hope we'll see you around the next show, which will be the last Thursday of July. Good luck and have a good summer, and we'll see you in about a month. Sign up on my Facebook page, Scott the Skywatcher, because that's where I go live with telescope stuff whenever I have the chance. Thanks again, and we will see you all hopefully under the stars.